Okay, so I'm going to try to approach this slightly different than my other classes. First of all, scratch out that top one. That's inappropriate. It's not section 10.1. It's section 4.4, the notes, section 4.4. And let's begin. Guys, what's a square root? It's simply the opposite of a square. Why does the square root of 9 equals 3? Because 3 times 3 is 9, right? We all understand that. So what's the square root of 16? It's 4. Why? Because 4 times 4 is 16. But if I ask you what's the square root of negative 9, it's not 3 and it's not negative 3. Because negative 3 times negative 3 is positive 9, and positive 3 times positive 3 is also positive 9. So this negative messes things up, and that's where imaginary values come out. So this is the first thing that we need to understand. When you take the square root of negative 1, we end up with the variable I. That means imaginary. Okay? So anytime you have the square root of any negative number, there's going to be an I involved in your answer. So it's going to be pretty simple. I mean, well, this part's pretty simple. So like before, when I would say, what's the square root of 25? What would you say? 5. And now, if I say, what's the square root of negative 25? You're going to simply say 5I. Ta-da, right? Okay. So if I say, what's the square root of 36? You would say 6. But if I say, what's the square root of negative 36? What would you say? 6I. Okay. Again, if you wanted to show your work, you could say, okay, the negative 36, I want to rewrite it as negative 1 times 36. And then I'm going to split the root. And then the square root of negative 1, that's I. And the square root of 36 is 6. So I times 6 is really 6I. See, all that work is kind of nonsense. You could just jump straight to the answer 6I. You guys get that part? Cool. All right, so let's go back to our notes here. Let's jump to this part. This doesn't even have a negative, but we should be able to get the answer. What's the answer to that one? 5, right? Why? Because the square root and the square eliminate themselves, which means that 5 is the only leftover answer. A square root is the opposite of a square. That's why they eliminate themselves. So if you ever wanted to get rid of a square root, you could square it. If you ever want to get rid of a square, you could square root it. They're inverse math operations. How about that? We just said that the square root of negative 1 is what? I. Perfect. How about here? What's that going to be?
Negative 1.
That's going to be negative 1 because the square root and the square eliminate themselves and negative 1 is left over. And that actually brings up another topic or another important fact. Right here, the truth about I. We know that's the square root of negative 1 that gives us I. But here's another very, very important fact. Please box this in. I squared equals negative 1. Now that's kind of weird, right? You have an imaginary. If you square it, the imaginary squared takes you back to a real number. It's negative 1. Okay, so I squared is negative 1. Do me a favor. Turn to a partner and tell them I squared is negative 1.
I squared is negative 1.
All right, thank you very much. Okay, so down here, I could have said, oh, the square root of negative 1, that really is I, and then I squared really is negative 1. All right, how about number 4? What's the answer there? 8I. So I guess at this point, let me just stop and ask you, is anybody confused where the I came from? No, right? It's simply, if there's a negative in here, you're going to end up with an I on your answer. Now, let's say it's not a perfect square number. Like, do I have any of those? No, I don't. But let me just go through an example here. If I had, like, let's say the square root of negative 20. Okay, well, the negative sign is going to come out as an I, and then you'll deal with the square root of 20 the way you normally would, right? How would we deal with the square root of 20 before? 4 times 5, and you split the root, right? Split the root. So you end up with what? 2 square root of 5. But let's not forget about the I that's out here in the front. So you really have I times 2 times the square root of 5. So the I is just like any other variable. If you had I times 2, it's the same thing as x times 2. You don't say x2, you say 2x, right? So the way to rearrange this guy would be 2I with the square root of 5 at the very end. So that's just another example, which we will go over later on in this lesson. But I hope we understand that already. Okay, so let's go back to dealing with just I, because it's pretty fun. Now, we already know where I came from. It came from the square root of a negative 1. That's really I. And we could also say that I equals I. Of course, I equals I, just like X equals X, or A equals A, or a banana equals a banana, right? I squared, we box that in. What's I squared, guys? -1. So everybody right here on I squared, go ahead and put -1. Now, I to the third. I could technically rewrite I to the third as I times I squared, or I squared times I. And just bear with me here. Go ahead and write down I squared times I. Why would I do that? I already know what I squared is. What's I squared? -1. So let me rewrite this guy. Let me rewrite it as -1 times I. And what's -1 times I? -1I, or just -I. It's going to look confusing on paper, but it's not confusing, all right? Just don't start saying, oh, it's confusing. Just stay focused, pay attention, it'll make sense. Which one do I love so far? I love this guy. I squared equals -1. It's beautiful because you have an imaginary, and if you square it, you get back to a real number. This is my next favorite one. I love this one because I could rewrite I to the fourth as I squared times I squared. Check this out. I squared times I squared. Now, we already know I squared is what? -1. So what I really have here is -1 times -1, which is what? +1. I love this one, guys. Box it in, highlight it, circle it, put some stars next to it. I don't know. Same thing with this guy. Both of these are awesome. I squared equals -1, and I to the fourth is +1. Turn to a partner, tell them I to the fourth equals +1. That's right. I to the fourth equals +1. We're going to love this. We're going to use this. Now, we're getting there. Let's take a look at, now, memorize this, right? I to the fourth equals +1. Why are we going to memorize it? Because check it out. I will be able to do any one of these using that fact that I to the fourth equals +1. Now, see the I to the fifth? I could rewrite that as I to the fourth times one more I. Is everybody following it? If you're not paying attention, you're not going to get this. You will be totally lost. Right? We just said I to the fourth equals what? 1. I to the fourth equals 1. I squared equals -1. So I'm going to rewrite I to the fourth times I. That way it gets me back to I to the fifth. This is really just 1, and 1 times I is just a regular I. Once again, I to the fourth is 1. 1 times I is just I. Okay? How about, what if I told you I to the sixth, even though it's not on here, might as well jot it down right here. I to the sixth. Well, let me read.
I to the 6 is after I to the 8.
Okay, I'm sorry. All right, then let's not do it. Let's not do it. We'll wait. What is I to the 8th?
I to the 4th times I to the 4th.
There you go. I to the 4th times I to the 4th, which is really just what? 1 times 1, which is 1. As a matter of fact, guys, I hope you catch on. Anytime you have I to any power that's divisible by 4, that's gonna be the answer 1. Right? So if I said I to the 12th, well, that'll just be I to the 4th times I to the 4th times I to the 4th, which is really 1 times 1 times 1, which is really just 1. Right? What's I to the 20th? I'm just writing it down here. What's I to the 20th? It's just 1. What's I to the 24th? 1. What's I to the 40th? 1. You guys see that? So that I to the 4th is beautiful because the answer is just 1. And if the power is divisible by 4, then you know you're going to be able to break it up into I to the 4th times I to the 4th, and it's all going to end up being 1. So knowing that, is that divisible by 4? No, it's not. But you could think, okay, how many times will 4 go into 6? It'll go in 1 time. So in other words, you have I to the 4th, and how many more i's do you need? 2 more. So what you're really thinking of, the I to the 4th, that's just really 1. You don't even have to worry about it. All you're really thinking of is I squared. And we already know that I squared is -1. How about this guy? I to the 10th. I to the 4 times I to the 4, and how many more i's do you need?
I to the second.
Right. So you could say I to the 4th times I to the 4th. You need 2 more i's, so you have an I to the 2nd, and we already know this is 1, and you have I squared. All you have to do is deal with I squared. What's I squared? Negative 1. Ta-da. Okay, so all we need to do, in a sense, is understand that I to the 4th equals 1, and I to whatever power, let's say I to the 25th power, is 25 divisible by 4? No, okay, so 4 times what gets you close to 25? Okay, so that would give you 20. What would your remainder be? 1 more I. Does that make sense? No? Okay, exactly. So since I know I to the 4th gives me 1, I'm going to rewrite it as I to something that's divisible by 4, 24, because this is going to be 1, times 1 more I. So what's my answer to I to the 25th? It's just I. Let me jump over here to the side. Everybody knows that I to the 40th is what? 1. Whenever it's divisible by 4, you're going to be able to group them as I to the 4th times I to the 4th times I to the 4th times I to the 4th 10 times, right? And then each one of those is going to be 1 times 1 times 1, which is just going to be the answer 1. So whenever you have a power that's divisible by 4, it's just going to be 1, right? So just divide it by 4 and see what your remainder would be, and that's what you really have to think about. So if I told you what's I to the 43rd power, well, go ahead and rewrite it as I to the 40th, which is going to be 1, times I to how many more? 3. So all you really need to do is figure out, that's 1, all you need to do is figure out what's I to the 3rd. And that's going to be negative I. Why is that? Because I squared is negative 1 plus 1 more I. So that's negative 1 times I, that's going to be a negative I. So I hope we understand that. Let's, whoops. Ugly, sorry. So we know where the I came from. It came from the square root of a negative. We know how to deal with i's to certain powers. We also need to know how to solve equations involving square roots when you end up with imaginary values. It's really easy. We've been doing this already. How do you get rid of the square? Square root it. So your answer is x equals plus minus. You have to put a plus or minus in front of your square root answer. Now, we already know that the negative is going to end up being what? I. So go ahead and write an I on the outside, but you still need to figure out 75. This is where you could use your calculator, the Casio, or you could think, I want a perfect square number. I need to rewrite it with multiplication to get a perfect square number. So what are you going to rewrite 75 as? 25 times 3. Split the root. Square root of 25 is 5. Square root of 3 stays square root of 3. Don't forget about the I that's out here in the front. Bring it down. And here's a fact, guys. When you're multiplying I times a number, it's kind of like x times a number. You're just going to put the number first and the variable second. So your answer right there will be x equals, don't forget about the plus or minus, 5 with an I with the square root of 3 at the very end. That's your answer right there. It looks ugly, yeah, but really the only difference of what you were doing before and now is that if you have a negative, you're going to end up with an I on your answer. Okay? Down here where it says find the roots, it's the same thing as the above questions of solving. Because after all, on the board, on the wall right there, it says that the answers are the same thing as solutions. They're the same thing as x-intercepts, same thing as roots. So on the instructions on your paper, it says find the roots. You're really just finding the answers. You're just solving. You're finding the x-intercepts. And how do you find the x-intercepts? You set y equal to 0 and solve. So right here where it says find the roots, you want to set y equal to 0 and solve, right? So on any one of these, just go ahead and set y equal to 0 and solve. So you would have like x squared plus 9 equals 0. But I like having the equal to 0 on the right side instead of the left side. So you could do that. You could put the equal 0 over here and erase that equal 0 on the left side. And then you just solve it like you normally would, right? Get x by itself by subtracting 9, you're going to end up with x squared equals negative 9. You're going to apply a square root. You're going to end up with x equals plus or minus what?
3.
But with that negative inside, what happens with that negative inside? It becomes an I. So what would we have as a final answer? 3i. There you go. X equals plus or minus 3i. So there's tons of more practice that you could do right there. Would you like to see another one? I don't know, pick one. 2 up there, 3 up there, or any one of these on the bottom?
3.
3 on the top or the bottom? This 3 up here?
Yeah.
Okay, that 3 up there. Okay, so let's go and solve that guy. Let's add 4, rewrite. We're going to have negative 2x squared equals 26. Then you're going to get rid of that negative 2, dividing by negative 2. You're going to end up with x squared equals negative 13. What's the next step? Square root, square root. When you apply a square root, your answer must be a plus or minus, or should have a plus or minus sign in front of it. And you can't really do the square root of 13, but what could you do with this negative sign? It becomes I on the outside. So let's pull out that I on the outside, and now you just have a regular square root of 13 that you can't do anything with. So there's your final answer right there. X equals plus or minus I square root of 13. Now if this would have been square root of 16, then you'd actually have 4i as your answer. If this would have been square root of 12, you could actually rewrite that as 4 times 3 and continue simplifying. But 13 you can't do anything with. Are we good, or should we see another one of these? You sure? One more or no? Which one? Number 4, down here? Okay, that one's pretty straightforward and easy. How do we get rid of that 9 in front of the x squared? Divide by 9, divide by 9. You're going to end up with x squared equals 25 over 9. You apply a square root, x equals plus or minus. Now when you do the square root of a fraction, it's like doing the square root of the top and the square root of the bottom. So you end up with 5 up on top, 3 on the bottom. There's your answer. X equals plus or minus 5/3. So we didn't even end up with a negative right here. So that wasn't probably a good one to do. That was something that we should have already known how to do. Anyway, I hope we understand that. Let's jump to this next part up here. This next part is pretty easy, okay? Let's first understand what a complex number is. A complex number is a binomial, 2 terms. It has your real part in front and your imaginary part second. Okay, real part in front, imaginary part second. And when you deal with the letter I, the variable I, just treat it like an x, all right? For example, what's 3x plus 2x? 5x. So right here, what's 3i plus 2i? 5i. Everybody write down 5i for number 2. That's pretty easy, right? The only thing that you have to watch out for, guys, is I squared. Because you should know that I squared equals -1. So whenever you have an I squared, you must replace it with the -1. So just treat it like a regular x, a regular variable, and whenever you end up with that variable squared, that's where you have to replace it with the -1. So let's all take a look at number 1 right there. What would 3x times 2x be? 6x squared. But right here, we end up with 6i squared, right? Let me really show my work. 3 times I times 2 times I. That's 3 times 2 times I, right? So that's really 6i squared. And I just said that whenever you have an I squared, you really end up with what? A -1. So 6 times -1 is what? -6. So that's your final answer for number 1. Pretty cool, right? So the operations are just like before, just like in Algebra 1 or pre-algebra. When you have x plus x, you just add them together. But when you have x times x, it becomes x squared. Right here, I times I is I squared. That's where you replace it with the -1. So this is just like Algebra 1 right here. What would you do? Distribute. What's your answer going to be? 12 plus 6i. Do you have an I squared here? No. So you're done. That's your answer. Again, the only thing you have to watch out for are I squares. When you have an I squared, change it to a negative 1. Okay, number 14, or number 4 is good. Let's distribute negative 3i times negative 5. Positive 15 with an I, correct? Okay, and then negative 3i times positive 2i. Negative 6i squared. Whenever you hear those words, I squared, something should go off in your head and think, hey, I squared equals negative 1. So let's replace it. I have the 15i, I have the minus 6, but I have a times negative 1. So what do I really have? I have 15i plus 6. Now this is the answer, but it's out of order. Remember, complex numbers have the real part first and the imaginary part second. So right here, I have it backwards. I have the imaginary part first and the real part second. So let's switch it around and get it in the appropriate form, I guess. So what would the answer be? What do you think? It's not that bad? It's not that bad. Will it get a little more challenging? Yeah, it does, but I don't want to scare you. Should we do 5? That's just, really? Yeah? Okay, let's do 5. I think it's pretty easy. Distribute the minus sign. You're going to end up with a negative 3 with the minus 5i. And then after that, you just combine like terms, right? Now, since you want your answer to have the real part first, let's take this real number 4, combine it with the real minus 3. What do you get? The real 1. And then combine your imaginary 2i with your imaginary minus 5i. What do you get? Minus 3i. There's your answer. So it's really exactly like pre-algebra, like algebra 1. You just simplify it. But if you ever end up with the I squared, that's where you replace the I squared with the negative 1. That's the only difference that we're doing on this section. Number 6 and 7 are fun. I like these. Of course, you have to distribute, combine like terms, cancel things out if you need to. But it gets fun. Yeah, FOIL. So if I say, let's distribute the 1. What's 1 times 3? What's 1 times 4i? 4i. Now let's distribute the positive 2i. 2i times 3. Positive 6i. 2i times 4i. 2 times 4 is 8. I times I is I squared. Now I already know that some of you already know that I squared is negative 1, so you want to do 2 steps in 1. I recommend write out the I squared. That way you could clearly see that that's going to become a negative 1. So what we have here is the 3 out in front, the 4i plus 6i, that becomes plus 10i, and the 8 times negative 1, that becomes negative 8. Does everybody see that? And now let's combine the real number 3 with the real number negative 8, and what do I get? Negative 5, and then bring down the imaginary part second. There's your answer to number 6. So again, it's just like before. You distribute, combine like terms. The only difference is if you ever end up with an I squared like we did right here, change that to a negative 1. Negative 1 times 8 is negative 8. Anyway, try number 7. 7's fun. I'm going to pause it. I want to see if you guys could get the right answer. Go for it. All right, let's distribute. 3 times 3, that's 9. 3 times negative 2i, that's negative 6i. Positive 2i times 3, that's positive 6i. Positive 2i times negative 2i, that's a negative 4. I times I is I squared. So yes, the middle terms eliminate, bless you. The last term has an I squared, which is really a negative 1. So I really have 9. And then over here I have negative 4 times negative 1, which is a positive 4. 9 plus 4 is 13. Beautiful, right? Now let me ask you this. What do you notice about this binomial and this binomial? They're the same thing, but one has a positive 2i, one has a negative 2i. Okay, now this is what we call a complex conjugate. When you have a binomial and you change that middle sign, that would be the conjugate, all right? And that's actually a vocab word that we need to know. That's what it says right here. The conjugate of a plus bi is a minus bi. Now, why am I giving you this vocab word? Because the complex conjugate is very important when you want to get rid of imaginaries in the denominator. So let's first practice stating the complex conjugate. Again, the complex conjugate is not changing all of the signs. It's only changing the sign of the imaginary, right? So if I told you, write the complex conjugate of 3 minus 2i, what would the complex conjugate be? 3 plus 2i. How about the next one? 5 minus I. How about the next one? 0.5 plus 4i. Now, we're not doing any math here. We're just stating what the complex conjugate is. How about the next one? Negative 3 plus 7i. Now, the real part doesn't change. It's only the sign of the imaginary that changes. Okay, number 5. The real part doesn't change. What's my answer going to be on number 5? Negative 2 minus 6i. Okay, I shouldn't have said answer. This is just the complex conjugate. It's not like we're solving. Right here, what would the complex conjugate be? Positive 3i, right? It's like if you had a 0 as the real part and you change this. So it'd be a positive 3i. How about the last one? You're only changing the imaginary. So that 9's not imaginary. That's just going to stay 9. Okay? So the complex conjugate, why is it so important? Why do we give it a name, complex conjugate? And why did I make you practice finding the complex conjugate of all these? Because we're going to use the complex conjugate to get rid of imaginaries in the denominator. Okay, so you don't want to leave an imaginary in the denominator. We're going to be doing some math, and if you end up with this as your answer, you don't want to leave it as your answer like this because there's an I in the denominator. Okay, so we're going to get rid of the I in the denominator by multiplying this denominator by its conjugate, its complex conjugate. So what is a complex conjugate? 1 minus 2i, right? Now you can't just magically multiply the bottom of a fraction by something. You also have to do it to the top. So let's multiply the top by that same 1 minus 2i complex number. And so this is like as challenging as it gets, guys. Wake yourselves up. Right now's the time to shake it off, pay attention. This is the final stretch, the last lap of the race here. It's kind of like doing 3 problems. Look at the top. 3 times 1. What's 3 times 1? 3. What's 3 times negative 2i? Negative 6i. Okay, ladies and gentlemen, this right here is going to be my numerator. I'm going to put an n because that's going to be the top part of our answer. Now let's go to the bottom. I want to ignore the top right now. Let me go into the bottom and let me distribute so I could find my denominator of my answer. So let me distribute 1 times 1, that's 1. 1 times negative 2i, that's negative 2i. What's positive 2i times 1? 2. Positive 2i. And what's positive 2i times negative 2i? Minus 4i squared. Perfect. Now we should know that I squared really becomes a negative 1 with the negative 4 in front. And we should know that the middle terms will eliminate. And this 1 out here is going to come down. So you have a 1 plus 4, and 1 plus 4 is 5. Now, ladies and gentlemen, this is the denominator. All right? So let's write our answer with the appropriate numerator and the appropriate denominator. So the numerator is 3 minus 6i. The denominator is 5. Now, the problem with this answer is that it's not in the correct way of writing a complex number. A complex number has 2 parts to it. It's a binomial. It's not a single fraction. It's 2 parts. You have a real part and an imaginary part. So what we need to do to this answer is take that divided by 5, this divided by 5, and split it to the 3 and to the 6i. So let's rewrite it as 3/5 minus 6 over 5 with an I on the second fraction only. And now we have it with the real part right here and the imaginary part over here. So that's the appropriate final answer right there for that one. So it's kind of like doing 3 problems in one, right? Actually more. You first need to know what is the complex conjugate of that. That's simply the same binomial, but with the minus instead of a plus, right? Minus instead of a plus. And what you do to the bottom, you do to the top. So you have one problem down here, another problem up here, and then you have that other problem of splitting that denominator into each of them. So this is a multi-step problem. I hope we could do it. Let's take a look at number 3. What would you multiply the denominator or the whole fraction by on number 3? That's right, the complex conjugate, which would be the same exact binomial, but instead of a plus 2i, it's a minus 2i. And what you do to the bottom, you do to the top, minus 3 minus 2i. Now, this one's a little bit more challenging because up on top, I actually have a binomial. So you have to put that binomial in parentheses, okay? So let's actually do these different problems. Let's focus in on the top, and there's not much space, so I apologize for that. 1 times negative 3, that's negative 3. 1 times negative 2i, that's negative 2i. Positive 2i times negative 3, that's a negative 6i. Positive 2i times negative 2i is negative 4 with an I squared. Again, the I squared is negative 1. So you could imagine that as being a negative 4 times negative 1, which is what? Positive 4. So we really have a positive 4 out here at the very end. The middle terms, you could combine them. They do not cancel out. They actually become negative 8i. And this negative 3 in the front, obviously I have it out here in the front. So right here I have negative 3 minus 8i plus 4. And the minus 3 and the plus 4, what's that? The minus 3 and the plus 4, what's that? That's positive 1. And let's not forget about the leftover minus 8i. Now, ladies and gentlemen, this is barely the numerator. Now, we need to go down to the bottom part and do the same thing and find the denominator. And then we could worry about putting the numerator over the denominator and splitting the fraction. Okay? So let's do the same to the bottom. Let's ignore the top for a little while. So we're going to go negative 3 times negative 3, that's positive 9. Negative 3 times negative 2i, that's positive 6 with an I. Positive 2i times negative 3, that's negative 6 with an I. Positive 2i times negative 2i, that's negative 4 with an I squared. Again, the I squared you must change to negative 1. Yes, it has a negative 4 right in front of the negative 1. Negative 4 times negative 1 is positive 4. Yes, the middle terms cancel out. And yes, that 9 comes down. So what's 9 plus 4? 13. Ladies and gentlemen, that's the denominator. The denominator. So let's put our fraction together as one fraction. We have the answer 1 minus 8i, that's on the numerator, over 13, that's on the denominator. Now, we cannot leave our answer like that. We need to split it into two fractions, the real part and the imaginary part. So what's my answer going to look like? 1 over 13 minus what? 8 over 13 with an I on the second fraction. Ta-da! What do you think? Now, number 4 is a little bit different. It's a little bit easier. Why is number 4 easier? Because you do not have a binomial down here. It's a single term, negative 3i. And you could just multiply by I to get rid of the I. Watch this. If I multiply by I and multiply by I, both top and bottom, multiply it by I, in the bottom, you're going to end up with negative 3i squared. And we know that I squared is what? Negative 1. So I really have negative 3 times negative 1. So what's my denominator really? 3. Okay, so I'm going to put a 3 right there. That's going to be on the bottom. That's my answer so far. 3 on the bottom. Now up here, I need to go I times 3. That's really 3i. I times I. That's really a positive I squared. And we should know that I squared is really what? Negative 1. So what I really have up on top is 3i minus 1. But you don't want the I first and the real number second. You want the real part first and the imaginary part second. So I need to rewrite that numerator as what? Negative 1 plus 3i. So that's just going to go up here on top of my fraction. Whoops. So here it is, negative 1 plus 3i. So here's my answer, but I can't leave it as a single fraction like that. I need to split it into two fractions, the first part being real and the second one being imaginary. So I need to take this 3 and put it on the first term, the negative 1. You're going to put it over 3, and then plus 3 over 3 with an I right next to it. That's my answer, but I could still take it a step further. 3 over 3 is really just 1. So my final answer is negative 1/3 plus 1i, or just negative 1/3 plus I. Pretty crazy, right? Now, we do have a homework assignment. It's listed down here. We're going to go to the book, page 250, numbers 1 through 8, all, and 11 through 41, odd. Now, you don't have a book at home. You have it in the class. You could get a book right now, or you could take a look at the video. On this video, obviously, I took a picture of the book, and you're supposed to do 1 through 8. So if you're watching this video from home, you don't have the book, you could hit pause and copy down 1 through 8. And then we're skipping and doing 11 through 41 odd. So once you copy down 1 through 8 on the video, go down to right here, 11, 13, and 15. You know what? Skip 17. Don't worry about that one. But you could hit pause right here on this video to copy these 3 down. And then we're going down to 19 through 41 odd. So you could hit pause right here on the video and copy down 19 through 33. And then you could hit pause on the video and copy down 35 through 41, because we're doing the odd ones only. And right here on the last 3, it says solve. Now, what do I mean by solve? You get rid of the 48 by subtracting 48, dividing by 3, square rooting. If you have a negative, you end up with an imaginary, and so on and so on. I will post the answers as well on Edmodo. Okay? So this will be the second half of the quiz. I will select questions straight from here. We're not going to learn anything else. We're just going to review this tomorrow. Also review factoring from the past so we could do better on the quiz Thursday.